basic end-to-end correctness, but all the tests of the library should be in the Proton Pass common crate. We also implemented some, let's say, not so fancy techniques for manual code splitting, because as WASM binaries can grow pretty big in size, we needed to make sure that we were not shipping to the clients 7 megabytes of a WASM file, because what would happen is that they would access the product, wait for a while until the final WASM downloads, and then they would start seeing something, because WASM that is loaded in the front end is blocking while you are loading the page. So we implemented some manual code splitting techniques in order to keep the UI as lean as possible, and then all the, let's say, heavy operations are performed in the background. And again, as before, this layer should be as lean as possible. So for manual code splitting, what we did is make use of one of the Rust Rust Cargo nice features, which is features itself. So just by annotating different modules like entry points for the Proton Pass web crate, we are able to only load partially some code of the crate when generating the final artifact. So in the end, what we're doing here is we're generating 3 different WASM files, web password, web UI, and web worker, each of them which only contain the necessary code that would be needed to run in this context. For the password, we are shipping the password scoring library as a standalone module, so it can be plugged into, let's say, a landing page or into the Proton registration form when you are creating a new Proton account. So it's able to only import this part. For the web UI, is the part that runs in the front end of Proton Pass, which needs to be snappy and as lean as possible in order not to block the content load. And for the web worker is this, let's say, extra context that the browser gives you for running background operations without blocking the front end. Because imagine that you need to score your 5,000 passwords that you have on your password manager. If you want to score them in the front end, what would happen is that you would click calculate. Wait for a bit, the browser would tell you, hey, this tab has timed out, and it would crash. But if you send it to the service worker, it can perform the operation in a background thread, and your front end stays responsive. And by doing this, in the service worker, we are also able to delegate this WASM file to be a bit bigger, so it can be downloaded in the background, and the user can continue using the application. And let's see a bit how does the code look like. In this case, it's really easy, because just by exposing your function, just by annotating your function with WASM bingeing annotation, you are able to use it directly from the TypeScript lamp. Then it's the same as any other Rust function. You just define your parameters, which in this case are WASM types. WASM is just the prefix that we chose for annotating our types that are exposed to TypeScript. And as a result, you return whatever you want to return. In this case, it would be a string. And this JS error is a type that is exposed by the WASM crates, that it's just an interface that will be converted into a regular JavaScript error in case an error appeared in your code. It's really nice because if your error implements the std error crate, the conversion to JS error is automatically done for you. So just by annotating your Rust errors with the, let's say, this error or a manual implementation of error, you have all of this done for free automatically. And this is how you would annotate your own structs and enums. As you can see, they are just plain Rust structs and enums, which you would then annotate with the tsify proc macro, and the serialize and serialize are the regular serde macros that we all use and love. And same as with serde, we can also specify some annotations, which in this case, we're implementing the into and from, which means deserialize from JavaScript to Rust and serialize from Rust to JavaScript. And it's really, really a pleasure to use these libraries because they don't get in the way and they just allow you to write your code. And if you want to expose something, annotate them, and then you're done. And we are also here implementing some from traits, some mappings between the WASM types that we're exporting and the ones that we're exposing from the common crate. But in the end, as you can see, it's not complex code. It's just mapping values here and there. And this is the only thing that the client crate should ever do. So this is all for the web crate, and this is our current architecture for the Rust library right now. So what we're using it for in 2025? First of all, we are validating some data, not all of them. But for example, for when you're creating an alias, we need to validate the prefix, it's all done in Rust. For validating an email address, it's done in Rust. For validating a host, like when you store your credential and you put a website there, in order to validate that it's a valid website, we're doing all the validation and code extraction and TLD mapping, all of that is done in Rust. TOTP parsing and generation, which seems easy because in the end it's just a URI. Derby Dragons. If somebody ever dares to read the small TOTP spec that Google wrote, you may be surprised about learning that Google didn't even follow it themselves, which is really fun. Password generation and scoring, construction of some payloads that we need to use in order to encrypt and sign some data, because even if there's 1 byte of change in any of the contents, then the signatures would not be able to match, and then all your data would be rendered unusable. So we really need to make sure that we are constructing all the encrypted payloads in the same way. Passkeys, we are doing all of the Rust operations, all of the passkeys operations in Rust. All the clients do is take the request from the website or the client application, send it to Rust, and then Rust does everything for you, and it returns the payload exactly how the operating system expects it. So all the logic, all the surgery, everything regarding passkeys is completely done in Rust. And we also offer some utilities, such as generating a QR code for sharing something quickly, or detecting the file type, because if you attach a file to one of your items, and you may see this tiny icon with a musical note in case it's an MP3, or a picture in case it's an image, all this file type detection is done in Rust. But as you can see right now, we are mostly using it for things that are input-output, as in the client calls the library, reads some result, and then acts on it. This is as far as it goes now. But what are we not using it for yet? We are not doing full item content validation, because initially it would have required us to re-implement every kind of item and all the data types again in Rust, and we didn't have time for that, unfortunately. We are not doing all the serialization, deserialization in Rust. We are, as of now, using protocol buffers as the single source of truth, and then every client is using auto-generated code by protocol buffers in order to serialize the data of the items. We are not using it for stateful parts of the application, so it's not interacting with the database directly, it's not interacting with file system, it's not performing any asynchronous operations as of now, it's not providing network communication, and for the crypto, we are only doing some in Rust because, unfortunately, as of today, there's not an easy way to do PGP encryption directly in Rust. There are some projects, such as Sequoia, but they are not mature enough, and they are not usable, as far as I remember, on WebAssembly just yet. So it would render one of the premises that we had, which is it needs to run everywhere. It would render it as not valid. So as of now, we are not using it for all crypto operations. And now some lessons that we learned across the way, and we learn them the hard way. First of all, monitor your builds. I cannot stress how important this one is. When you have everything automated, you are pushing code, you are reviewing merge requests, everything is being generated by the CI, the clients can just npm install and run it. I mean, it's fine. Monitor them, because it's really easy to inadvertently add a crate that makes your build go 3 times bigger. And it's really easy that this happens. Also, read the docs for the crates that you use, especially for the features, because the example that we will see right now is on the regex crate. Like, if you need to run any kind of regex code in Rust, it's no-brainer. You just add the regex crate written by the great Burn Sushi, and it works, and it's fast, and it's huge. Like, it's really big. But in the documentation, it states that you can disable some of the features that you probably don't need in order to trim down the size. But if you don't read it and you don't monitor it, you're going to encounter that your users are downloading 3.5 megabytes of data just because there's a Unicode table there that they are downloading, and you probably don't need to use it. So please monitor your builds. Also, it's worth adding a builds tab or a CI job that monitors the artifact size and, if possible, the size change on each merge request. Here we can see the thing that we added on our internal CI, which, as we can see, just by tweaking the regex crate flags, we were able to go from 1.5 megabytes to 500 kilobytes, which may not seem like a lot, but it's a 3-time increase when we added it that we just didn't realize it. And the regex crate was the main reason that we added this. Also, if you are including Tokyo as a runtime, you probably don't need to include the full variant. Just import what you're using, because it will help keeping these sizes down in the end. For mobile libraries, it may look like it's not that much of a deal, because you just download the application, you have like a fancy spinner bar while it's downloading, and then you can use it. But on web, what the user is doing is entering some website, clicking enter, and then they want to use the application. This would probably impact really negatively on their user experience. And here is the example that I was saying, that we added these checks about finding that regex added 3 times the build size to the library. Then monitor your performance. It's really fun to be able to just call Rust code from your TypeScript project, your Android project, but it comes with a cost. Every time that you're crossing the boundary, what you're doing in the end is serializing your data, be it in binary size, in JSON, or however the binding library is doing it, but you are doing it every time. So if you send a massive payload from the client to Rust, and then you send a massive response from Rust to the client, you are serializing and deserializing every time that you cross the boundary. And in case of arrays, check whether calling a function for each element or calling just one, but with a huge array, check which one is faster, because sometimes the answer is not the same. For example, if you, let's say, are in the front end and you have 10,000 elements, and you want to calculate the score of the 10,000 passwords, what you would probably do is use a service worker, as we said before, that allows you to run the operation in background and the front end stays snappy. What happens here is that in order to invoke the service worker, what you're doing is send a message. And this message contains the payload that you want to pass somehow, because the service worker will not have all the information that you have in the front end. So you would say, okay, I will send one message with 10,000 elements. It will serialize on the other side, and then this other side, which is the service worker, would say, okay, I'm going to call Rust in order to score these passwords. It will then serialize it again, and deserialize it in Rust, calculate it, return it, deserialize in the service worker, serialize again, because you're sending the response, deserialize in the front end. So what happens here? When the front end sends a message to the service worker, if it's one message, it's okay. But if you start sending one message, let's say, per password, and you have 10,000, the browser will rate limit you. So it will say, nah, I don't allow you to send that many messages. So you will not score all the passwords. So probably it makes sense to send one big message to the service worker. But what happens in the service worker? If you send one big message, in our tests, we found that it's slower to serialize a really big chunk and deserialize it on the other side, calculate it in the for loop, and then return it. This one was slower than just spawning parallel async jobs that call Rust one by one. And I think, if I remember correctly, the speedup was about 4 times or 5 times. So by sending one big chunk from the front end to service worker, and on the service worker spawning one async job for each password, it was really, really faster. So make sure to monitor your performance. And also don't focus on micro benchmarks, because Rust is really good at optimizing hot code paths. But in the end, your bottleneck may not be Rust. It may be your target platform. As I was saying, the browser may rate limit you if you send too many messages. So make sure that you are performing your benchmarks on your target platform and not on your cargo bench, and that's it. It's a good starting point, cargo bench, but make sure to test it on your target platforms. Don't rush it. Start progressively. I get that the meme of rewrite it in Rust is fun, and there are projects such as Fished where they have achieved amazing engineering feats, but everybody in the room don't need to be the Fish developers. Don't rush it. Start slow. Start with non-critical features. Start with new developments. Go slowly. Make sure that you nail the basics before approaching really huge refactors that will probably just end up with you pulling your hair. It happened to me. And also make sure that if you are the one developing the Rust library and you have client developers that are going to use what you're building, have a tight feedback loop with them. Make sure that they are able to use it. Make sure that they are satisfied with the quality of it. Make sure that it's at least on par with what they were using before. Make sure that they like using it, that it's not a burden. Nobody wants to end up being like the guy that knows how that thing that nobody wants to touch works. You should be able to encourage them into saying, hey, see how cool this is? I encourage you to contribute code to this and be part of the movement that we're trying to do, which is write things once, review them, and make everything available to all the clients at the same time. Also, automate everything you can. We are engineers here, we know how things work. Nobody wants to need to generate a library that only that guy knows how to do it and he's on holidays. Nobody wants to do that. Automate everything that you can. Do all the automatic processes on the CI that you can, because if anybody needs to generate a library, make it as easy as possible, such as push a tag, and then everything is already available for them. Documentation matters. Make sure that your code is documented. Make sure to add comments. Rust provides you with a really good documentation framework, which is RustDoc. It's really easy to add it. So make sure to add documentation, and if possible, maybe evaluate what you're rewriting. I'm stressing again the first point, maybe you don't need to rewrite that thing in Rust. Start with boring things. The fancy ones are fun, but start with boring things so you can really focus on what matters, which is developer experience, if possible. Because DX matters. If your artifact is a binary library, make sure to get feedback, not only in the performance, but also on the APIs that you're exposing, on how you're packaging the things. Make sure that your client developers if possible, don't even need to compile the library themselves. Go one step further and provide them with something that they can use straight away. For JavaScript, just publish an npm package. It's not hard. For Xcode, you can just publish an Xcode project. It's really easy. You just need to copy the bindings into a directory, create some Swift file that defines the package, pull the libraries, and that's it. It's really a no-brainer. You just package it in a zip file that they can download, import into their Xcode project, and that's it. And for Android, packaging into an AIR is also not a really hard thing to do. Also, things that we have learned across the way. If your team is not already well-versed in Rust, favor readable code versus clever code. Everybody feels super fancy writing this triple generic nested code, but in the end, if you are a new joiner and you are new to Rust, you may read the Rust book, you may start coding your first pet projects in Rust, but if you see a 3-level deep type, you probably are going to be scared away and will probably close the window, which is what I would probably do. So sometimes, even if dynamic dispatching is a bit slower, boxed in is fine. You can just allocate some memory in the stack and be done with it, and your reader from the future will definitely thank you. If possible, also add tests for the platform that you're targeting. In our case, before we have seen how we added tests for the web library, and they mainly serve as a way for developers to understand how to use the library, because you may have a really nice API in Rust, but what matters in the end is what API are you providing to your end developers. If you provide an API with 6 parameters that it's fine for testing and you want to pass all the dependencies to the Rust code, then that's fine. But if possible, keep it to the bare minimum to what you're exposing to the clients. Make it hard to use it wrong. And also, there are some things that need to be done sometimes in some languages. One is the one that I was mentioning before. If you're passing a U64 to your Rust code, I mean, it's nice. U64 is a supported type. Kotlin also has a long type, but if you want to pass it to the native library, you will need to call things like toLong, which for a regular Kotlin developer is not something that they have encountered on their day-to-day. So these kind of tests really help them in order to see how to call this function. Or for example, if you're passing a U64 from JavaScript, you will need to wrap it on begin, which sometimes in some IDEs is not even recognized. You need to enable some TypeScript mode for that. But by doing this and providing this set of tests, they can just copy-paste into their product and they can see that your application is working. Also, another thing that is important, debugging is not as easy as in target platforms. Like imagine that you are developing an iOS application, you just set a breakpoint, click run, and the next code stops there and you can inspect all the stack trace. On Rust, this is not the way. First of all, because the debugging experience in Rust is not as good as on other languages. And second, because what they will have in the end is just a native library, usually compiled in release mode, that they will just import and they will not be able to set breakpoints on. So make sure to provide ways for your developers to know what's going on, be it by dumping information into the file system, running prints, implementing some kind of logging system, but make sure that they can know what they did wrong. Returning errors is fine, but if we can decorate these errors with some information that is not something serialization error, but you can print something like, hey, in this JSON, I am missing the challenge field, let's say. It would be really helpful for them, for knowing what they did wrong, and for you in order to fix it or add a test for it. Again, for the tests, we have talked before about how we did it in the web platform by using the Bunch shell. And it's really easy. You just annotate your test the same way as you would do it with any JavaScript code, with describe and test helper methods that are already provided to you by any testing framework or by Bun directly in our case. And then you can just import the WebAssembly file and the TypeScript bindings and start calling it. So you can make sure that you have documentation as code and that you have API regression tests. So in case you change any of the parameters of the functions, you would be able to detect it really easily. One thing that happened to us was that when trying to detect the credit card type, we would allow initially only the number to be passed, like this is a huge number, but then we decided that we wanted to change it to string. And in JavaScript, it's like, hey, this is a parameter, sure, go with it. But if you use TypeScript and with the TypeScript bindings that we have, it would have been a compiler error. If we had used JavaScript, first of all, shame on us for using JavaScript directly, and second, we would not have detected this kind of breaking change. But as you can see, they serve for two purposes, and for mobile, there's a problem that for running target tests, you would need to either start an emulator for Android, which is costly and usually not really doable on CI time because they are really heavy and they need a lot of RAM and they need a lot of CPU, and it's really, really slow and really flaky. But for iOS, you can just run the simulator on the CI, which are, I think there are modes for running it headless, but they are also really slow. There's a project which is experimental, and I am not endorsing any of you to use it, but we have been using it with great success. It's called Gobly. It's an open source library that uses Unify under the hood in order to generate bindings directly for the JVM. So you can run tests that run directly on the JVM, which makes it really fast and really easy to add tests. You just import JUnit and are able to start writing tests for it. And as you can write them in Kotlin, you can make sure that you encounter all the things that you would see in the client code for, in this case, for Android. So all these 2U long thing that you would need to know before using it, you would face it right here. And these tests, as they are run directly on the JVM, they can be run on the CI, they run really fast, and it's really, really easy to expand it. So for client developers that start writing in Rust, then they maybe can also start writing tests for the target platform. So here's a bit of information nugget. Check this project, I think it's really cool. They are still not up to the latest version of Unify, but I think it's worth taking a look to it. Pain points. Like up until now, we have mentioned all the bells and whistles for Rust, but there are some trade-offs that we must know before using it. The first one, imagine that you are using a library, let's say for WebAuthn request for generating a passkey, and you want to expose that type to the client libraries. You are not able to do so because these types are not on your crate, so you cannot annotate them. So you either import the crate and annotate it, you make a merge request and wait for it to be updated and merged and published and all of that, or you do what you should do anyway when you're crossing a boundary, which is you manually copy all the structs, annotate it with the platform-specific types, and then you maintain the binding yourself. It's not a fun thing to do, but it is what we have right now. We have tried to dedicate some time to create a proc macro to improve this process, but it's not easy due to Rust not having reflection. So we are still trying to work on a better way of solving it. Also, as we have mentioned, debugging is not as easy as attach the debugger, run, and then the IDE stops it for you. So, well, a byproduct of this is that it encourages developers to try to write a test that reproduces their crash. So in the end, what you are doing is encouraging TDD, which is a really mean way of saying, this is what we have, we cannot do better, I'm sorry, but this is what it is right now. Also, as we mentioned before, on big payloads, the serialization and deserialization is not negligible. So if you send, let's say, 10,000 passwords to score, it's going to take some time only serializing and deserializing on the other side. Even if the calculation is fast, all the message passing can be a really big overhead. Also, on mobile, we had to deal with some release optimizer rules. It's called ProGuard, which is the thing that optimizes in the end your final build in order to strip down unused code and really optimize all the code paths. But if you don't add some rules for it, it would strip out all the Kotlin bindings. So you would not be able to call into the final library because it would not have the bindings, so the code would crash only when built in release mode in production builds. So it's not a fun thing to debug. So beware of this kind of optimizer rules on your target builds and make sure that they are not optimizing the things that they should not be optimizing. And also, as we mentioned, on Android, the library that is used for interfacing with native code, which in this case is JNA, it can only be used in instrumentation tests. You cannot use it in unit tests. So you would need an emulator in order to run the end-to-end tests. As of now, we are solving it by using the Gobly project that we mentioned before. In the end, what would be really desirable is be able to spin up an emulator and run the entire code in the target platform. But it comes with a series of drawbacks. And also, auto-generated code generated by Unify is not always easy to read, nor idiomatic, and sometimes it doesn't contain everything that you would need. For example, there was an issue in a couple of versions ago in Unify, which didn't mark all the interfaces that you are defining on your file, on your UTL file. They were not marked as sendable, which is like the send version of Rust. So you were not able to pass them across threads, which is a really common thing to do in iOS. So as they were not conforming to the sendable protocol, the client developers were not able to use these Rust services that we're providing in an easy way. They would need to instantiate a new one every time that they wanted to use it, which makes it a really not so efficient memory usage of the resources of the system. Another pain point, which is web. WebAssembly may not be supported in all web browsers. There are really paranoid people. I mean, there are many paranoid users who use Proton, but there are people who really go the extra mile and they really trim down what their browser can do, but yet they expect everything to work. But WebAssembly does not work if you have some lockdown or super private browsers, so they would not be able to use the application. This is something that you may need to know. For now, there's not much that we can do, but it's something that it's worth mentioning. Also, code splitting, not being a first-class citizen, makes you need to do the thing that we mentioned before, which is like manually annotate the code that you want to import in each of the contexts. So we would like to have a better option for code splitting, but unfortunately we don't have it. So this is what we need to do. And for offloading heavy computations, this is the thing that we have mentioned regarding the message passing, that the browser may throttle your messages. So in the end, what will be happening is that you are losing operations, which is also not desirable. But this is what we have learned, this is what we're doing, but where we are heading to. This is what we have right now, which is each client has its own copy of the Rust library that it's using in order to decrypt or perform some kind of operations, and then the application is communicating with the Proton servers. But we want to go one step further, with a minor change in the position of the icon, but which conforms a really massive change in how everything works, which is this. We want to make the clients only interact with the Rust library and make the Rust library be the one who interacts with Proton, who interacts with the resources, who interacts with the database, who interacts with the file system, and make it be not only the bridge, but be the driver. Make it be the one that fetches the data, that tells the client, hey, store this into the database, that tells the client, I need you to, let's say, request the fingerprint of the user. But we want the Rust library to be like the core one. Not the core as in the core features, the core as in the core of the application. So we can have one core library, and each client would be like an implementation detail. Each client would be the one implementing some functions that the Rust library cannot do, but make the Rust client be the one that does all the cryptography, all the HTTP, all the session management, that does everything for you. And how we're going to do it? As a company, as Carlos has said before, many teams have been experimenting with Rust and have enjoyed it so far. We have formation, we have people who are building the solid foundation for everything that we are going to need in all the products, which is, for example, session management, database access, network requests. And they are also exploring other ways of doing the same things that we are doing. For example, some of us are using raw Unify bindings, but others are experimenting with other libraries that try to achieve a similar thing, maybe more like a framework, which is Crux in this case. And by providing this set of shared libraries, we can unify not only across clients, but also across products, how everything works, which makes it really easy for client developers that start developing a new product to don't need to focus about integrating all the core libraries that we have for each platform, just implement this, and all of the rest is already handled for you, which makes it really good as a company effort in order to provide homogeneity to all of our products. And also, as a company, we're trying to unify practices and benefiting from learnings in other teams. We're trying to schedule regular meetings about sharing what we have learned, about sharing what resources are available up until now, and for sharing all the code that we have been doing so other products can already benefit from it. And also for Plus client code, one of the first changes that we want to do is the one that we have mentioned, which is instead of the client calling the library, make the library call the client for the things that it cannot do, but for the rest of the things, make the library be the one that drives all the interaction with the user and with the server. We would also like to move away from UDL towards Unify annotations, because there's a way, same as we have seen on WAS and BcnRust, that you can annotate your structs. There's a way to do that with Unify. But we didn't take this approach in the beginning because we didn't want to break APIs all the time. And it's really easy to just go to the struct, add a new field, and just be exposed into the clients. But you need to handle this carefully with backwards compatibility, adding default values, adding nullables. As we didn't have these kind of guarantees in the first place, now we do because we have the Goblet tests, but as we didn't have them, initially we set up with UDL, but now we would love to move to the annotations as they can be really helpful in order to reduce code duplication with the UDL files. And we would like to start integrating, as I have said, more implementation details into Rust, such as database, network, session management, data validation, which is one of the main things that we would love to do in Rust, because as of now, we have the data validation split through all the platforms, but we would love to do it in a single centralized place. And also serialization and deserialization. As of now, all the clients have a copy of the protocol buffer files. We would love to move that into the Rust library and allow one single serialization point for all the clients, apart from moving all the business logic from the clients to Rust, and providing same abstractions for device features, such as the secure storage for storing your local encryption keys, fingerprint reading, and file system access. If we can provide a same abstraction over all of these that clients need to implement, then we can decouple all of the things that are implementation details in the Rust library and just depend on abstractions, which is a really good thing that we would love starting to do. This is one of the approaches that we are taking right now while exploring this approach, which is defining a trait that defines the features that the client will implement. I don't care how, I don't care where, it's just that I need a client that defines this kind of features. Things like get local key, get file, check if a file exists, store a file, and perform some kind of PGP encryption decryption with user keys and opening the encryption keys. This is the set of operations that a client would need to implement in order to use the client that we are building right now. And this is what the Rust code would look like if we had this. The core crate would have this: a pass client that has an HTTP client, a cache that has some implementation of the cache, be it in memory, be it in file system, I don't care. And then the client features would be an implementer of the client features trait that we have mentioned. You would construct it, and from then on, all the Rust code that uses pass client would be implemented in the Proton Pass common crate, and then we would be able to start implementing all of our business logic without depending on the actual implementation. It would just be a dependency that the client would implement, and we would be able to use it. And this also allows us to do a really, really interesting thing, because as we have one common crate and one client crate for each platform, what we can do is we can decide if we delegate all the implementations to the client or if we can implement some of them. For example, for mobile, we can just straight away use, let's say, an SQLite library binding that is available already in these platforms, and implement, let's say, do A and do B in Rust. So the target applications only need to implement do C, which could be, for example, perform some user verification, a fingerprint on Android and a Face ID on iOS. But the Android and iOS applications would only need to implement one part of all the client features that we need in the common crate. But for example, in web, we may not be able to do any of that, so we would just expose all the trait to the browser land, and it would be the TypeScript developers who would need to implement all of that. But having this kind of separation of all the dependencies here and being able to implement partially or completely in Rust in the client crates makes it really flexible for starting to add new things. Maybe initially we want to delegate all the implementation of the database access to the clients, but if we are able to provide a really good abstraction or maybe connection to the database in Rust, we can start adding it in the mobile crates, which would then defeat the purpose of make it as lean as possible, but it would then evolve into the crate that we were mentioning before that is able to drive the application in the end. And all of that being said, the overall satisfaction with the Rust library is quite high by the developers. They all love it, they like using it. We are trying to encourage more people to contribute to it, but as of the user point of view, they are really, really satisfied with it. And if all what I have said sound interesting to you, feel free to check our careers page or to check with our HR team in order to apply for one of the Rust positions that we have available and be ready to join the adventure. And with that being said, if anybody has any questions for the talk that I have just given, be my guest to ask them. That's it. Thank you very much. No questions? Anyway, yourself?
Yeah, well, thank you for the amazing talk, and I'm actually happy that you're experiencing that experience with Rust. What I'm actually kind of surprised is the velocity of your team, of like going from the passkey in September, like from POC to November, so September you start, November having the POC, and then how many Rust programmers were involved and how experienced you were.
Rust programmers, we were.
No, that shit. Like ChatGPT for Rust code, I'm telling you, it's shit.
It's 2023, so ChatGPT was not an option back then for Rust, I would say. Rust programmers, I would say we had Carlos, we had me, we had Adri, who also helped with this, but yeah, mostly on the Rust part it was me, and on the client integration it was probably one developer for each platform, yes.
Impressive.
Thank you.
I can imagine like, the amount of coffee, tons of it.
We run on coffee, yes.
Okay, congratulations.
Thank you very much. I mean, start small, start with a couple of functions. And once you get all the integration done, like integrating the thing is what...
Yeah, I mean, like we use Rust. In what we do is a completely different thing that you guys do. We use it for injecting the Western machine in envoy proxies, for rate limiting services and authentication and authorization, and our rate limiting services written in Rust. But still, like the ramp up of new developers to Rust is like hard.
It is.
It's a steep learning curve. So I'm actually surprised that in just a few months you deliver.
We're lucky to work with such amazing developers and really, really talented people here. You had a question also?
Yes, it isn't clear for me when it comes to the front end of those three applications. Is there anything that you share? Is there any code that they reuse, or is that separate front end for each platform?
When you mean front end, you mean like the actual final application, right? Not the Rust code, but the front end, the display.
The graphical description of the behavior of the graphical elements.
Okay, no. So for the graphical elements on Proton, we mostly implement our products on native platforms. So Android is a native application, iOS is a native application, and web is also a native application. So on regard of the front end side, there's really no code sharing. I know that there have been some experiments with things like Flutter or similar technologies, but in Pass we don't use it. We go straight native in our case. Go ahead.
So you're clearly dealing with sensitive data, right? Password and stuff like that, right?
We are.
I was wondering, have you considered like supply chain attacks, stuff like that? You know, how do you manage your dependency?
Yes, for supply chain attacks, we first of all have to like kind of separate things. One is the GitHub page where we publish all of our code that anybody needs to be able to compile themselves. But on our internal infrastructure, especially on really sensitive crates such as the network management, the session management, we try to, first of all, work with cached versions that we can audit and pin. We run all sorts of hash verifications for ensuring that there are no supply chain attacks as in man-in-the-middle attacks. But in the public code that we publish, all of that is already stripped, and we have also our own cargo internal registry for our own private crates. So everything that goes there should be at least audited or reviewed by people in the company. Back there?
You mentioned before that like the support of cryptographic libraries is not that good in Rust. What's the outlook there? Do you think that it will catch up with what you have in C, or?
I mean, first of all, we need to distinguish between two kinds of cryptography. The symmetric cryptography, which may be like AES or similar things, it's fully supported in Rust, and the libraries there are really top-notch quality there. But for the asymmetric encryption, which we use PGP, the state-of-the-art is, let's say, not there yet. There are projects like the one I mentioned, which is Sequoia, that is starting to like take shape of what the end library may be, but it's like really low level and it's not really usable out there, out of the, let's say, theoretical field. I really hope that somebody would fund work on it, or that we have some really smart people like the ones that started the Ring or Rust TLS implementations in Rust, that they can shift into implementing this kind of libraries, but as of now, I don't know if they will catch up soon. We would love for them to, but as of now, this is what we have right now. I'm sorry. No more questions? Then thank you very much, everybody, for attending here.